Hey guys, what's up? Welcome to day 50. Today we're looking at I got a lot on the plate today. So today we're going to look at average value of a function. We're going to continue some of the rules from yesterday, and we're going to talk about unit analysis and how we know how to choose the right units. Okay, so I'm going to start with actually the second thing there, rules continued. So there are just some things that can be helpful for us in terms of calculating definite integrals in reference to even and odd functions. So I'll call this rule 6. Pick up from yesterday. I think we got 5. Okay, so a reminder on even functions. Even functions are symmetrical about the y-axis. So in an even function, it might look something like this. And what we know about even functions is every corresponding x value, its opposite x value has the same y value. So basically what it means is f of x equals f of negative x. Right, so if you think about this function, right, if I have the point 3,4, then there's a corresponding point over here that's negative 3, positive 4. Okay. So when we're dealing with even functions, and we have a lot of them, x squared is an even function, x to the 4th is an even function, x squared plus 6 is an even function. Cosine x is an even function. We can take some shortcuts when we're doing definite integrals. So let's say f of x is an even function. If we have an even function and we do a definite integral from a negative value to that same value but positive, right? Imagine like negative 3 to 3. What we're going to see here is the area under the curve on both sides is going to be the same. So what we can do then is just say, okay, if the integral from negative a to a of f of x, if I want to calculate that, a way I could do it that might save me some time is just do the integral from 0 to a and double it, right? So basically what it's saying is this blue region and this blue region are equal areas. They will be as long as that function is symmetrical. So I could change this to the integral from 0 to a of f of x dx and just multiply by 2. Okay? That can save us some time if we recognize something as an even function. Okay. Similarly, we have, I want to talk about a rule for odd functions. For odd functions, right, it might look something like this. Where every f of x is always equal to the opposite of f of negative x, right? So if there's a point out here, just to keep it consistent, if this point is 3, 4, then there's a corresponding point -3, -4. You actually saw this on one of your homeworks. Examples of odd functions would be like, let's see, x cubed, x to the 5th. Sine x is an odd function. So when we see odd functions, when we integrate from -a to a, again, this only works for odd functions. Well, what do you think that integral would be equal to? Well, what's happening here is we get, again, two equal-sized regions. Well, one of them is negative in value, and the other one is the same value but positive. So what's going to happen if we integrate from -a to a? Well, hopefully you can see, before I write it, that it's going to have a value of 0. So that can be helpful with odd functions. If we ever see an integral, right, from -pi to pi of sine x, we know the answer is 0 because sine is an odd function, and it's going to have however much negative area it has, it's going to have the equal amount positive area to cancel each other out. Okay, so let's get to the new thing for today, average value of a function. Okay. So I'm just going to give you the formula of this. So definite integrals are very helpful because they can help us calculate the average value of a function on a given interval, a, b. And we just do the definite integral from a to b of f of x dx, but we multiply that by the fraction 1 over b minus a. Okay? What this might be helpful with, like, let's say you have a graph that charts your car's miles per gallon efficiency. You might have a graph that does something like this, right? So this is your miles per gallon, and this is time. You might want to say, well, what's my average miles per gallon of my car, right? Well, since it's a curved line like this, it'd be hard to calculate the exact average because it's constantly changing. Yeah, but we can do the integral from whatever time we want to begin to the time we want to finish, and that will tell us what our average value is, right? Our average value would be somewhere kind of in the middle of those two. Maybe our average value would be somewhere in here. Okay. So let me show you a couple of examples. Okay, so here's the problem. I want to find the average value of f of x when f of x equals 6x squared plus 1 on the interval 0 to 2. So again, when we think about this, 0 is like my A, 2 is like my B. I can get my solution by doing 1 over B minus A times the integral from A to B of f of x dx. The solution to this expression here will give me the average y value, right, the average f of x value on the interval 0 to 2. Okay, it's not a line. You can't just look at the value at 0 and look at the value at 2 and just add them up and divide by 2 because it's a curved function. It doesn't work that way. So let's just calculate this thing out to show how it would work. 1 over 2 minus 0 is going to simplify to just a half. I'm going to do the definite integral here. So I'm going to bump the power and then divide by that power. Okay. The key as you're solving this is just to remember that that 1/2 needs to be out front the whole time. I keep the 1/2 out there until the very end, and then I'll take half of my final answer to get my average value. So as I continue, I'm going to plug in 2, plug in 0, and subtract them. But a lot of times students forget to write the 1/2, and they end up getting the wrong answer because they forgot about their 1/2. So keep writing it over and over again. That's the first thing I'll do. Every time I do a rewrite, I'm going to put my 1/2 out front. Okay, so now I'm going to plug in 2. So I'm going to have 2 times 2 cubed plus 2 minus 2 times 0 cubed plus 0. Now I can see that that second term there is going to be 0. Okay. But I have to calculate the first. 2 cubed is 8. 8 times 2 is 16. 16 plus 2 is 18. And 1/2 of 18 is 9. So what that means is that function, 6x squared plus 1, between 0 and 2, it has an average f of x value of 9. Okay. The other thing that I'm going to do an example here, and what I'm going to do is it's going to be a calculator problem. So let's say we have this function here, r of t equals 7e to the 2t minus 1 plus t cubed. And let's say r of t, that function, is the, I don't know, fuel efficiency. Let's do something different. Well, whatever. I'll think of something here. Okay, but what I want to do is find the average R. Okay, how about this? It's rate of fuel consumption. Okay, So R of T is the rate of fuel consumption of a plane, where R of T is in gallons per minute and T is in minutes. Okay? So if I asked you, what was the average rate of fuel consumption over the first 5 minutes? So my question is about fuel consumption. My function is in terms of fuel consumption. So I want the average value of R of T over the first 5 minutes. Okay, that would be on the interval 0 to 5. So if I want to figure out the average fuel consumption over those first 5 minutes, right, I'm going to do this by doing 1 over B minus A, so it'll be 1 over 5 minus 0. Times the integral from 0 to 5 of my function R of T dt. Okay. Then I can just go to my calculator and complete this integral, right? Just so when I enter it here, that 1 over 5 minus 0, I can just call it 1 over 5. Integral 0 to 5 of my function, which is 7e to the 2t minus 1 plus t cubed dt. So I'm just going to go to my calculator here and enter that. I don't need to be in radians for this problem, but I'm going to get ready for in the future. Okay, so I'm going to go ahead and do 1/5 first. So I'll do my fraction bar. I'll do 1 over 5. Then I'll call up my integral by doing math 9. Integral 0 to 5 of my function was 7e to the 2t minus 1. I can use x, 2x minus 1, plus t cubed, so plus x cubed, dx. And I get that. So that's my average fuel consumption in gallons per minute. Looks like this thing uses a lot of gas, right? So I can use my calculator to figure these things out as well. Number 5,703.151. Now let's talk about the units here. Whenever we do an average value of a function, the units are always going to be the same as the units of the function we're integrating. Okay? And if you think about it, if R of T is in gallons per minute, when we integrate that, we're taking gallons per minute times minute, so we'll get gallons. But because of that fraction out front, you're once again dividing by minutes. So it ends up back in the exact same units that it was before. Again, this integral is going to give me a unit of gallons, but I'm doing 1 divided by minutes out here. Gallons over minutes is gallons per minute. So I just want to talk about that a little bit. Let's just do a quick unit analysis thing, and then we'll be done. Okay. So when we do a definite integral, okay, when we do a definite integral to find the units that our answer is going to be in, we want to take the units of the function times the unit of the variable we're deriving with respect to. So let's say our units for R of t are miles per hour. And let's say our t units are hours. So when I do the integral from a to b of R of t dt, my unit is going to be, we looked at this with the Riemann sums, but I'm taking this and I'm multiplying by this. Miles per hour times hour. My hours are going to cancel and I'll be left with a unit of miles. Okay? Let's think of another one. R of t. Let's say the unit is people per day, and t is measured in days. That means the integral from a to b of R of t dt, the unit would be people per day times day. The days are going to cancel and my unit will be in people. Okay. Let's look at one more. Let's say A of t dt is a unit of inches squared, and let's say t is a unit of inches. Okay. Then our integral from a to b of A of t dt, our unit would be inches times inches squared times inches, which would be a unit of inches cubed. So anytime you do a definite integral, the two variables you're multiplying together. Okay? What's an important thing here is if our function is a rate, then the integral of our function is going to be an amount. Okay. So if R of t is the rate that people enter a store, then the integral from a to b of R of t dt will be total number of people who entered store between time A and time B. Okay? Because again, rate that people enter the store might be people per minute or people per hour. When we integrate it, we're going to get people, and the context there is that's the total number of people who entered the store. What we need to be careful of is that average value unit analysis. So taking one more look at that, Okay. Using this rate of people entering the store. If I have 1 over b minus, right, the integral from a to b of r of t dt is the total number of people who entered the store, but 1 over b minus a times the integral from a to b of r of t to d, that would be the average rate that people entered the store. Because it's the average value, right? This is telling you it's the average value. So it'd be the average of R, which is so it's the average rate that people entered the store. Okay, which means the unit would still be the rate, so it'd be like people per minute. Okay. So the unit there, the unit to just the definite integral would be people, but the average value integral would still be whatever R of t's units were, which might have been people per minute. Okay, we'll end there. Kind of a long video. We'll talk about this a little bit more in class on Monday to get ready for our test that's coming up on Thursday of next week. Talk to you guys later. 2 chains. Bye.